Thank you actually for being here. It's 5 in the afternoon, so usually people go home at this time. So thank you for being here. Yeah, I will actually give you a short introduction to NLP and chatbots. Actually, it's a 2-day training that I squeezed to 6 hours actually for O'Reilly, and now I try to squeeze it to less than 1 hour. And thank you for being here, having a blockchain presentation in the other room. So, I see some of my students here. So just an introduction about myself. I actually have a PhD in computer science and artificial intelligence. So this is actually my domain, artificial intelligence. This is what I'm doing for about 10 years now. I'm also the co-founder and owner of a company called PROIDEA. We actually place actually not so far away from here. And yeah, I'm publishing some scientific, some papers like this one that was recently published, last year, about skin cancer, right? How to actually diagnose skin using machine learning. Regarding actually unit tests, I will have another speech on Thursday at Test Dive conference about how to use machine learning, not really for unit tests, but actually for functional tests. How to use machine learning to improve the automated tests. So I would say how to automate the automated tests, right? In a better way to make it faster. So if you would like to contact me, you have the contact details here. You have my business card here. If you want to, after the speech, you can ask any questions during my presentation. And I'm sorry for the quality. It's not because my slides, it's more about how it looks like. Chatbots. I know you heard about chatbots for sure. Some of you are using chatbots or any kind of bots. Actually, chatbots, the same are artificial intelligence, IoT, big data, and many others. Actually, it's a buzzword, right? So, and for sure you have used some chatbots. Some of them are working well. Some of them are actually annoying, right? If you are just getting all the time some ping from on Facebook or anywhere else, just asking you some stupid question, and if you are answering, it doesn't really understand what you are typing, right? So I would like to talk about how actually to build intelligent chatbots, intelligent bot, and how actually it evolved in the last couple of years. So actually, chatbots is a different interface. So you know, actually in the late 90s, we had web pages, right? Internet web pages. So we had a web interface. Then we moved to the mobile interface. So everyone has a smartphone now. And next we have. And now we have also chatbots, which is a conversational interface. It's not that it actually is a replacement for the previous one. It's more like it's an add value. Just it's a different possibility to communicate with customers, right? So that's actually what chatbots are. So it's just a different interface. And yeah, there are different types of chatbots. So depending on the interface, we have automation, we have audio, text, right? So we have Alexa, which is audio, we have text. Most of the actually chatbots are text. We have, depending on the privacy. So, well, the chatbots that we actually are using now are public ones, right? So they are actually public, available. Usually using some open source tools in the back, but not always. And depending on that, because there are some industries like fintech, some banking industries, for example, they are regulated, and some of them actually need to be on site. So you cannot use any Amazon API or any different API for that because it's not allowed by the law. It could be, but they don't want to. The guys from banks, the lawyers, it's more complex thing. And obviously the usage, we have superbots, we have domain-driven bots like superbots like Google Assistant, for example, right, Siri, and we have some domain-specific chatbots like, for example, LawGeeks, for example. This is a good example of a lawyer chatbot that actually is giving you some suggestions when it comes to the law. It's actually dedicated to lawyers. So as you see, there are many implementations. Some of them are tools, some of them are just bots that we can use, like Siri, right? Here, Chat Fuel. you have Dialogflow, and many, many others here. So there are many, many implementations now, but obviously the big players like Amazon, Google, Apple are handling obviously the most popular ones. But still companies want to do that, want to implement their own chatbots. But actually what you need to also know is that chatbots is the same like artificial intelligence, machine learning. It's something that it doesn't mean that always you need to build a generic chatbot that is actually working for in any case. Let me give you an example. I was at a conference in May this year in Berlin. It called Race of AI. When I had a speech about fintech and machine learning using fintech, and we had a booth. There was one actually director from one company from Silicon Valley coming up to our stand, and we talk about business. And then he actually told me one story that one company, yeah, I know, boring. One company actually came to him, giving him $2 million on the table. Please implement a machine learning solution for us. So he took the money, they implemented the solution, they actually deployed to production, and it's working well. But they figure out that the solution is replying to 50 emails per day. It's not too much, right? It's working well, but 15 emails. The guy actually came to the customer and said, well, why actually you spend so much money on that? It's cheaper actually to hire someone replying to the emails. It takes 1 hour for such a person, and then this person can do something else, right? And what they said, well, yes, that's true. But now our company can say that we are doing machine learning, that we are doing artificial intelligence. So they spent $2 million just to be able to say we are doing artificial intelligence, right? Doesn't make much sense, but that's true. It's a true story. So it's more about buzzwords, and the same with chatbots. It doesn't mean that you need to build, a super bot every time you have a challenge. Sometimes actually a simple solution is good enough. So yeah, the other question is, are the chatbots? Do you know who this guy is here? Yeah, obviously. He's the godfather of artificial intelligence, and he actually there was a Turing test that actually we are able to say if the artificial intelligence, if the solution is artificial intelligence or not. It means that if let's say we have a chatbot and we are discussing with the chatbot, on the other side there can be a human or artificial intelligence. If we are not able to distinguish, it means that it's artificial intelligence, and this is what the Turing test actually is saying. But are the chatbots currently available really intelligent? Depends, right? We can say, okay, Google Assistant is intelligent, Siri is intelligent, but it's not really a binary classification, really, because what computers actually do good is they calculate well, right? If we ask a chatbot, for example, what is the, 1,254 multiplied by 526, let's say. A human it will take us time, right, to calculate that. And a computer will just do it like that, because they are good on that. So we can actually easily distinguish if it's a computer or a human. We have different type of chatbots. So we have some generic ones, and also some domain-specific here. And some of them are actually rule-based. They are general AI, they are the hardest one here. We have retrieval-based and generative-based. What does it mean? I will actually explain you in a minute what a retrieval-based chatbot is, what a generative-based chatbot is. But more or less, it's a generative one is actually that is generating the answers, right? Actually, all of them are generating answers, but the way how they do that is different. So let's say the simplest chatbots, the the rule-based chatbots. So this is how actually it looked like. So we have a phrase list and an answer. So let's say we have a question list and an answers list. So we go through the questions list, figure out if it's working well, I mean, if it fits to some of the questions. If it fits, then we just reply with an answer. Obviously, the answer can be, like here, you have the brackets here, where actually you can put some data in it, but still, this is something that we need to figure out if the question is right. It's a stupid way. I mean, not really stupid. A simple way of figuring out what the actual user would like to ask for. And there are many possibilities. In Python, you have some libraries that actually allow you to compare strings, for example. And using some regular expressions or just some libraries like this one, you can actually use them to figure it out. It's not really the perfect way to do that. Yeah, that's why it's simple. There is a better way to do that, NLP. NLP, so natural language processing, so we can actually, okay, you don't see anything here, sorry. You can see more now, I guess. I'm sorry for the quality. So we have NLP, you have NLU, which is a part of NLP. So NLP is natural language processing, and NLU is natural language understanding. So it's a more difficult, a term that's actually about understanding, not really processing the natural language. And you have different terms here, like the sentiment analysis, for example. What else? Yeah, summarization, for example. I don't know if you know, there is a startup, Berlin startup called Blinkist. Anyone used before? Okay, so it's, but probably most of you are reading books, right? So a book is about, 200 pages to 300 pages or more. And Blinkist actually, they are wrapping it up to 15 minutes, right? So, and I know they are not using NLP yet, but they are trying to do that. For now, they are doing it manually. But actually, using NLU and NLP methods, you are able to do that. You are able to squeeze the 400 pages into 15 minutes as audio file. And it means what's actually inside, so kind of a summary. There are actually many different methods here that are related to NLP, like part of speech tagging, named entity recognition, and many others. I will show you some of them. Yeah. And some of the popular NLP methods, not only NLP, are tokenization, lemmatization, and stemming. Let me go to the Jupyter notebook. Here we go. Yeah, rule-based. So, oh damn. I guess it's fine, right? No, it's okay. So let's imagine that actually, the NLP thing is actually quite difficult, because let's imagine we have the word developer. My company actually had a booth some time ago at a conference, and actually one of the persons that was visiting us was asking for some construction work position, because we have so many developers position. Actually, it's totally different, right? When we say developer, we mean software developer. But there are different developers, right? So there are people that are doing construction work. They're also called developers. And that's actually a way how actually some sentence has some different meanings. Like here, this is actually from TextBlob, where actually we are getting the definition of the word developer. We have two definitions. And there is no software developer here. Okay, so regular expression, I will just skip this one, because we have not enough time. Similarity, something that I mentioned before. So you have two words, trains and training, and we can obviously check the differences. I mean, how similar both words are. We can also do it on the whole sentence, and this is the way how actually rule-based chatbots are working. You have also the jellyfish solution here, and so on. Yeah, here we go. Here's a good example of tokenization. So we are using here here we have the regular expressions that are available in Python, and we are splitting the sentence into words. Do you see the mistake here? What's wrong? What's wrong with actually splitting it in such a way? Well, it is. I mean, it's not a word. I mean, it's we can say it's a word. What's wrong? Dot, right? Because dot is a punctuation mark, which say us that it say us this is stop. This is stop at the end of the sentence, and whatever comes next, it can be related to the previous sentence, but it doesn't need to be. So NLTK is one of the libraries that is actually mostly it's a common libraries for NLP. It's written in Python, and you can do the tokenization, which is dividing sentences into words, but it will also take care about the punctuation mark, like dot, like exclamation mark, and so on. So it's a different way of actually dividing the sentence into words, into tokens actually, because tokenization means we are dividing the sentence into tokens. There is also something like lemmatization. I have a good slide here, just a second. Here we go. Right? We have 3 words, do, does, doing, but it means the same. It's do. And we can actually, using lemmatization, we can actually change the word into the basic form. We can say, okay, it should be a verb, it should be a noun, it should be something else. But the basic form of this word, it's easier than to actually work on the sentences, on the dictionary, on the tokens, if we have the same word and have the meaning of it. Okay. And we have stemming, which is something that I'm not using it so often. But it's there are different implementation of stemming. Oh, one thing that I just forgot. If you see here, part of speech here is verb. Right? We can change it to noun. We can change it to something different. Here you have the whole list of for NLTK that actually you can do it. And stemming is it's similar to lemmatization, but it works differently. It uses also tokens, but they are taking the root and cutting the rest. And depending on the implementation, they can cut differently, right? So you have 2 implementations here: Porter schema and Lancaster schema, and they are do it in a different way. You can see here, for example, and actually only here in this sentence. But they are different. So they are cutting it and actually taking on the root. It can be useful for actually recognizing what actually the sentence is about. And here you have actually an example. So I will leave it for now because you don't have laptops, you don't have it set it up. So it's more like a workshop and a challenge task actually. Okay, machine learning. So going next. So we have NLP. I just showed 3 methods of NLP. And we have machine learning. Anyone used machine learning before? Here? Any methods? Obviously. Implemented? Yeah. So machine learning is a part of artificial intelligence. Machine learning is only one way of actually implementing artificial intelligence. There are different ways of doing it. So, but for now, it's the most popular. I would like to be still alive. I mean, see a different way of actually implementing artificial intelligence. But for now, machine learning is the most popular for many, many years now. And we have also deep learning, which is a part of machine learning, which is actually, it's a neural network that has many, many layers, and it's quite complex, usually using some raw data to see actually the connections, and now it's using Google Photos, for example. It's using some deep learning methods. But machine learning doesn't only mean neural networks. You have different methods for that. And why I'm saying that, because for NLU, usually you use some machine learning behind. You're combining natural language processing with machine learning to get natural language understanding and understand the meaning of the sentences. How machine learning works, we have two phases. We have the training phase and the prediction phase. The training phase usually takes time, a lot of time, usually. And the prediction phase takes less time, usually less time, because we have also we have already the model. What is the model? It's a mathematical function. So it is just a function. Easy thing, right? But actually, the training here is about getting the labels and learning, actually setting the weights. Usually we have weights, but it depends on the method. We have weights where actually we are setting the value of the weights. Weights is just a huge matrix. Usually it's huge matrix with some numbers inside. And the training phase is about setting the numbers in it. And this matrix is actually then used for this function and as a model to distinguish, actually predict the next cases. Labels in this case is the information about, let's say, going back to my PhD. I have developed some algorithms on skin cancer. So let's say we have images of moles, and label is information if it's a cancer or not on the image, right? So we have the information if what is actually on the image. In case of deep learning, it's working a bit differently because we have usually raw data. We don't have all the feature extraction here. So you don't extracting the features like if it's big, if it's small, what's the shape of the mole, and so on and so on. And yeah, natural language understanding. I'm just presenting only three methods: part of speech, noun chunk, and named entity recognition. Part of speech, what's a part of speech? It's a noun, it's a verb, and so on. Noun chunk actually is a method actually to get nouns, and named entity recognition is about getting the information, what actually the sentence is giving. So we get some information like Karol is, for example, the name, right? And Kraków is a city. These are the entities here, named entities. Here I have an example. Broadcasting today, live from Kraków on Chatbots. On the bottom. Oh, yeah, sure. Yeah. Big enough, right? So here I have the part of speech, so punctuation mark, adverb, noun. Noun chunks. This is the method to actually get the nouns from the sentence. And named entity recognition is getting today is a date. And look, Kraków is location, right? So that's what about. What is it about? And an example. Here we go. Here's actually a speech, Trump speech, how to actually do it with spacey. Anyone used spacey before? Rasa? Oh, more or less, okay. I will talk about it in a minute. So you have an example here of part of speech. In this case, we are using spacey. So thank you. It's a comma, right? So it's a punctuation mark. So you have a verb, and we are actually dividing into part of speech. Quite easy to do with spacey. Here it is how it looks like, importing spacey, then going through. And if you would like to get this part of speech, is token part of speech, then that's it. Easy thing. Here I have actually the previous example, broadcasting today, using spacey and getting the part of speech. You have the noun chunks also here, Kraków and Chatbots. from the previous sentence and name it entity recognition. So you have the date and the GP. GP means location. As you see, it's easy to do that, right? It's easy to actually recognize what is the sentence about. If we take, okay, it's today and it's in Kraków, and yeah, the chatbot is missing. Here we go. Here's also chatbot. So we know what the sentence is about. We can actually recognize more about it. But how does it look? How does it actually work? Anyone did some word vectorization before? Okay, so as I mentioned before, computers are actually good at calculating, doing some math stuff, right? And well, the examples that I showed you before are about well, it's text, it's a string, right? And if we divide it in tokens, we have tokens. But well, strings are not so easy to find. If I don't know, king is similar to queen, or what's the relation between two words? It's not easy based on to do it based on just strings. So what we are doing, we're actually moving it from a string representation to our number vector representation. Actually, and each word is represented by a vector. What does it mean? We have a n-dimensional space that allows us to find the similarity between words in the feature space, right? So we see similarity between some words. How to do that? We need to actually use some text, like let's say some corpora, to train it. And the words that actually are in the sentence nearby, we have some window that is some of some size that actually are moving, and then in this way we're actually trying to figure out which word is similar to the other ones. But actually there are many methods actually to do that. There is not only one method. Yeah, here is an example of how to do that. So you see the numbers here. It doesn't need to be two-dimensional. There are some methods actually to make it two-dimensional. And this is how it looked like, more or less, for the small example. But I have a nice link here. Yeah, I know a lot of errors here. Here we go, word to vec. And Spacey already it's already learned. So we are loading the English language and comparing 3 sentences. Warsaw is the largest city in Poland. Croissant is baked in France. No? Croissant. So, I did a mistake. Yes. Oh, I'm sorry. If it would be German, I would actually don't. It would be easier for me. And animal is a large bird, right? And as you can see, we are comparing each sentence to see the similarity based on where actually the words are placed in the feature space. And as you can see, the first sentence is obviously equal to 1 compared to the first sentence because they are the same, exactly. The first sentence compared to the second one is 0.71, third one 0.64, and so on and so on. So we see that actually the first sentence is closer to the second one than to the third one. Maybe because Warsaw, Poland, maybe France, maybe this is because of that rather than large bird, right? So let me give you another example. This is actually a project that was developed at Warsaw University. And as you can see, you have, okay, you don't see it now, better? Yeah. So you have X and Y axis here. Obviously, all of the words does have a vector that is not 2. I mean, there are not 2 values, there are many values, but we are able to actually to make it 2-dimensional. There are some methods, TSNA and so on. And as you see, there is a relation between the king and the queen. So we train it, and we see that it's a woman, man, and so on. So let me give you an example of, let's make an empty this example. Okay, let's say we have x-axis. Let's say it's west, and so west, east, and we have city and country. Country. Here we go. Okay, look, give me an example. Okay, it was Warsaw, Poland. Cool. What's more to the west? Paris. Right? Paris, France. Okay, what's between? Obviously, right? Germany. Here we go. London. England. It's not really more to the west, but it's more north, but we don't have really north, we have west, east. So in most texts, they are considered to be more west. And so on, so on, so on. So we can actually change. So we know actually the relation between England and London. So there is a relation between two words, and we see that it's actually based on the dictionary that we have learned from, the text that we learned from. In most cases, it comes with a word west more often than Paris, than Berlin, and Warsaw. That's a good thing. Good question. Well, it will not really appear. I mean, it will be totally different. That's a bad thing, that you need to really have a good dictionary, good text to actually to train it. So if it didn't appear in the text, then it's hard to do that. But actually, this is why actually you are training for a long time, because you have the dictionary is quite huge. I mean, the text is quite huge. Yeah, it depends on that what text did you use, because you can actually use some text from movies, for example, right? And there will be some cities that doesn't really exist, or you can take The Witcher, for example, right? And also there will be some sentence that doesn't really exist in the real world. It's just fantasy, and you will get it here. So it always depends. So we have many examples here, just showing you how does it work. And going back here. Okay, this is an example. Let me go back to the slides. There you go. So this is how it looked like, as you saw. So we have relations between king, queen, man, and woman. What's interesting is that if you do some add, for example, king, if you add king to queen and do a minus, I mean. Subtract it from the woman, then you will get a man at the end. So it's just numbers, vectors, so you can do real calculation on that, and you will get some other values. That's quite interesting. So figure out what will happen if you subtract, I don't know, Paris and Warsaw. I don't know if it will be Berlin, maybe somewhere in the near, I don't know. Yes. Exactly. That's it's not perfect, but it's better than the previous example to understand that. And there are actually many ways actually to do that. At the end, it's just a multiplication of weights, right? The matrix and the vector of the following word. And there are many methods actually to do that. One of it is bag of words. TF, IDF, for example. You can use also transfer learning. This is actually a method that is mostly, well, it's common when it comes to deep learning, where actually you are distinguished between the objects. And this is also something that you can do. You can use the n-gram model, which is the most, I would say, okay, bag of words is the simplest one, and the second I would say is the n-gram solution to do that, to actually do the representation of a word. To a vector, you have skipped out vectors and so on. In this example here they use Glove, I guess. Yeah, it's a different way of actually doing it. So there are many. Here's actually how bag of words is working. So we have broadcasting live from Kraków. This live training is on Chatbots, and this is actually how you do the representation of two different words. This is the first sentence, and then there's the second sentence. So you're putting all bag of words. You're putting all words in the bag, and then representing it by the because this is the bag of word, and then we are doing the representation. It's binary. Does it exist in the sentence or not? Quite simple. Obviously, this is not a real, alive example. It's just an example to make you understand how does it work. And based on that, we have retrieval-based chatbots. Retrieval-based means we have some questions, we have some responses. We are putting it into a method that is actually building. We are building a machine learning model to get the intent and get the entity of a sentence. And based on intent and entity, we are able to give the response. An example. Retrieval-based. Here we go. Here's Rasa. It's an open source tool. Actually, the guys who implement Rasa are based in Berlin. A very powerful tool, and it's open source. Here's an example where I actually use it as a service with an API. And if we say, hi, the intent is greeting with a confidence of 100%. Easy, right? Simple example. But we can have more. We can learn, we can train them to actually extend the number of sentences and words with intent and text. Like, hi, good morning, and so on. So here's affirmative, like, yeah, indeed, and so on and so on. So actually to train Rasa, to make it working, to distinguish the intent is quite simple. Just couple, I mean, here are about 14, I guess, examples to train it. So not too much. As you see, it's actually used for a chatbot used for recruitment, right? Please add new candidate to the pipeline, and so on. We have a new pre-screening coming, and so on. So I actually use it as an example for the recruitment, and goodbye, and so on and so on. And this is how it's working. A new developer. So this is something that we didn't saw this example before in the training data, and we see that into this candidate ad with a confidence 33%, which is not high, but comparing to the other ones, it's higher. So we could take this one as the intent, and yeah. This is actually what is the retrieval-based chatbots about. So we are understanding the intent. If we would like to get some what kind of data we would like, we extract the entities and then execute the task based on that. So this is an example. Okay, you don't see it. Yeah, I know, Champions League, maybe it's not the topic. I did it in June, so this was the hot topic then. When I did the example, what are the recent Champions League scores? There was a message to the NLP. View behind it, and the intent is Champions League recent scores. So that's quite easy to do. And how does it learn? So because the other thing about chatbots is, I'm running out of time. Wait, I still have 4 minutes. So how does it look like? We get the intent entities, get the state, because at the beginning the chatbot doesn't have anything, right? So when you say to hi, say hi, and we know that we said hi, so the state changed. And there's an action based on that. We update the state, so we know that we said hi already, so we can actually do something else now. Because if the user will actually type again hi, then we can actually reply not again with hi, but we already did it before, or something like that. And this is how does it look like, and this is how actually the context can be also changed, because the context is another thing in chatbots that is quite difficult. How does the Rasa learning process work? So we have, what is the next training? This is a string, so we are using some vectorization here, then the classifier, and then getting the intent. So we have some machine learning behind it. Analogy. I know I'm talking fast because we still have few slides and just a couple of minutes. So natural language generation is about generating the text. It means that based on the question, we can generate an answer that is logically, properly with a proper grammar, and we didn't have this answer before. So we don't have it we didn't have it in the training data set. And there are a few methods that can be used for that. N-gram model, again, one of the simplest one. Recurrent neural networks, autoencoders, this is our deep learning methods, and GANs, also deep learning methods. This is how it looked like. So we have the window, this is the size of 3, and we are just moving, getting the N-gram model, and then training it. Here's a good example. Here we go. I just will, yeah, here's the N-gram model. To do that, I used here Monty Python, I guess. Text 7, no, Wall Street Journal. And it's generating some text. Here at the end, we have to buy the funds made available person to the market system, he says. Makes sense. It was generated by a simple model, N-gram model, and it generates based on the text that they had, that actually we train on. So this is this is a simple example, but most of the examples actually are using some more complex solution like the RNN, so recurrent neural networks that actually we are able to set the size of the answers, set the size of the question, and based on that we are able to train and get the output. We can also use the LSTMs with some memory inside. Autoencoders, you can think about the feature vector as a zip, right? We are zipping the information, and then based on that, we are actually generating some data where we have some noise. Where we have some noise here, actually adding. We are adding some noise here. So we have the encode decoder, and we have also the GANs, where if you have the generator and discriminator, where actually the training ends when the discriminator doesn't distinguish between the fake and the real data. So we are putting also some response in the questions here, and almost there. So what are the advantages? The rule-based chatbots are predictable, clear, easy to develop. The rule-based, retrieval-based are the most common now used, because the generative one are generic and hard to develop, really hard to develop. Only the big player like Google and Amazon can really handle that. Usually, because it's not about the computer power, it's more about the data sets. Because we need to have huge data sets to do that. So data sets is actually crucial in this case. And yeah, why also retrieval? Because we don't need to have too many questions answered actually to start with. What are the bottlenecks? Root-based is usually too simple. The retrieval, it's not a generic solution, but in most cases it's fine. And generative-based, we need to have a huge data set actually to do that, to make it working really, that it makes sense. Okay, where to go next? Really two last slide. I'm actually O'Reilly trainer, so please join me. You know O'Reilly probably, right? The guys that actually are publishing the books with the animals on the cover, and I'm actually also giving trainings there on Safari platform. That is a platform from O'Reilly. So please find me there. I'm also giving trainings, workshops actually with Python on building intelligent chatbots, or also sentiment analysis, how to actually distinguish if the customer is happy or not, and how to build such a library from scratch. Because in each case is different, and again, the data set is here crucial, and we show how to do that properly. Thank you. Any questions? I know it was fast, but it should be a few days.
Okay, so let's say I have a Discord channel. Discord is like Slack. Well,
let's say Slack. Yes.
There's a let's assume it's a Slack channel, and I have some gamers that join, that come, and then they tend to ask questions like, why is the server empty? Why is no one playing? Things like that. And I would like to build a bot that would recognize those kinds of questions and give a meaningful answer, like we are playing during the weekends, for example, or something like that. How would you tackle this problem without resorting to checking one or two words like dead, empty, because that's what we are doing right now, and I would like it to be a little more intelligent.
Rasa.
Sorry?
Rasa. That's the answer. This is the tool that actually you should use.
That's a one-word answer.
Actually, you should try it out because as what you said, the sentence can be it can be 2 words, it can be 5 words, and but there are some keywords inside, right? That actually so I would say the rule-based can be used here, but it will be not really so intelligent. So it will be do many mistakes, and this is, I guess, what you have now. And I would just move on to the retrieval-based chatbots, to Rasa, train it with the JSON. It's, I don't know, 15 minutes of work actually to do that, and the training takes also, it's very, very fast because you don't need to have thousands of examples. I think 100 is more than enough in your case, and that's it. So we had this kind of things that we did such an implementation in the past. So it really makes a difference.
All right, thank you.
Thank you very much for your talk. Is there something as well around making it not only intelligent but also sort of believable? For instance, a way to add emojis or fillers like in chatbots. So emojis or fillers like, oh, let me check even if it already knows, or non-colloquial things like,
making intelligent is also about sentiment analysis, right? So you can build a library like we did. There are some libraries that are available, like Core NLP, which is, can be used for sentiment analysis. There are a couple, like a few of libraries also available in Python to measure the sentiment. There are not so many that actually measuring by emojis. We have implemented such. That is working, and we also giving a training about it, how to make it working with emojis as well. Actually, we use it for short messages, like Twitter ones with a lot of hashtags, with a lot of emojis. How to do this is one of the things how actually you can distinguish if someone is, sad or happy. You can distinguish between different sentiments and make it more intelligent. So make this as a factor, as an input to the learning, to the training phase of the method.
A question about security. Is it possible to ask the chatbot such a question to retrieve some data we don't want to expose?
To retrieve some data that we don't...
Yes, such an attack, let's say.
It's possible, obviously. You know Microsoft, right? Do you know Tay, this chatbot, the Twitter bot? Yeah. So this Twitter bot is, let me give you an example. Just a second. I should have it somewhere here. Tay. Yeah, here we go. This is a, I don't know if you can read it. This is a bot, chatbot, actually a bot, Twitter bot that was developed by Microsoft. And in 24 hours, from a teenager chatbot, it became we are going to build a wall and Mexico is going to pay for it. It's not Trump. I mean, it was before Trump actually became president. And this is actually how I would say, some people found a backdoor to train this chatbot, this bot, to make it, to transfer it from a teenager to a racist, to a Nazi person who hates Jews and doesn't like Mexicans. So yes, it is possible to do that. So obviously you need to secure it in such a way that actually no one will give you the data that you don't really want to. So it's about retraining, right? Because they retrain the model all the time, and the data that came retrain the model to make it a racist, like in this case. Funny example, but
Thank you.
Does Rasa understand Polish words? Because you showed previously Witai, the tool, and I used it and it understood.
It's about the dictionary, right? So Spacey does allow you to use German, English, French, Spanish. Polish is also on the list. I mean, you can use Polish. I guess it's still in beta version, but you can use it. So it depends on the language and dictionary that you're using. So yes, you can. but it depends on that what you want to do and what solution you would like to use. Because some libraries, some solutions like Spacey does have support for Polish, but some Polish is not the most common language, right? So English is the most common, then Spanish, Chinese, and so on, and Polish is somewhere, the second half of the list.
You show bot. On the first slide, it's white. No. The tools from Python, and I wrote a bot that use Polish words using this.
You mean first slide? Okay.
Oh no. Next.
This one?
Yeah. This robot.
This one?
Yeah, and it understands
Which?
Polish words. And even you can send an audio file in Polish and make it to text, and you can next
Yeah, but it
showing
depends on
time
the,
and
as I said, this depends on the data set on the dictionary. Just to give you an example of Alexa. Have you tried Alexa before? It's a good thing. I have a Jupyter notebook showing that because I use text-to-speech from Google and Alexa, right, to get the text-to-speech to audio, and then send it to Alexa to get the answer. And what I did, I tried with different as a British person and an American in English. And if you put it as American, everything works well. But if you change it to British, it doesn't work so good. So it depends, right? Even the accent can change. And especially if you make it faster or slow it down, then it makes more difficult for Alexa, even it's so advanced solution, right? Anyone else? Any questions? Okay, the last question, because in 30 minutes I have a lecture at Jagiellonian University, so I need to go to the campus. Yeah.
Okay, so I'll try to make it quick. Regarding Polish, the Polish language, there's a library that's called Morpheusz that allows you to perform morphological analysis. I'm not sure if I'm translating it right. What do you think? Would it be possible to pre-process the Polish language with Morpheusz and then feed that pre-processed data to Rasa, for example, to obtain a better way?
But you want to translate it?
No. I mean, I want to obtain the meaning of the words. I mean,
In some way, it could be possible, but as you see, it's just JSON that you use as a training data set. So you need to think about how to do it properly. Not sure about it, to be honest. I need to figure out if it's really... First of all, it makes sense, because if you have Spacey, why don't you use Morpheus? Why, right? Because Morpheus is an NLP actually library, right? So, not sure about it. But you can drop me an email and I can figure out for you if it's possible.
Right,
because I didn't work with Polish language so much, to be honest. It's more about German and English.
Sure, thank you.
Okay, so thank you very much. If you would like to contact me, here's my business cards with all the details. Call me, drop me an email. Thank you very much.